What's going on, everybody? Welcome back to another Granularity.ai tutorial. Today, we are going to talk about something that I think is pretty cool, pretty revolutionary in how we're able to combine different platforms, different tools together to achieve an outcome. So today, we are going to be creating a RAG process using Autogen plus OpenAI assistance plus the new OpenAI O1. Now, if you have been keeping up with all AI news, you'll know that OpenAI's O1 model is pretty much the revolutionary new thing. Um, I'm not going to go into depth on kind of the what distinguishes it from other models, but the O1 apparently has better reasoning and thinking than past GPT models. For example, I think we all thought GPT 4.0 was kind of or just GPT 4 was kind of the best thing for a while. But it turns out that this OpenAI O1 series of models is basically something completely different and revolutionary from what we've experienced with GPT-4. So they kind of gave it its own name, mainly because what makes it so powerful is that it's able to perform deep analysis, deep reasoning, and deep thinking. I believe it has, I think it's called better chain of thought. Um, uh, uh, I guess chain of thought thinking, if you want to call it that. Um, but it's able to have somebody here PhD level reasoning, thinking, and analysis. So again, this is kind of where we're beginning to see AI stand toe to toe with a lot of like the smartest individuals in their respective fields. And again, I don't think AI is meant to necessarily compete with individuals in their respective fields, but is necessarily meant to be there as an assistant to help with articulating and piecing together new discoveries that can further human existence and humanity as a whole. So I already have an assistant created. I'll show you guys here, um, where you'll see that I have an AI developer. You are an expert in creating AI applications. You help users define new AI applications based on their task. Please use the files that are stored for context information on how to develop AI applications. Now, I kind of already have a file here within this assistant that is going to be this large 396 page Python code for artificial intelligence, Foundations of Computational Agents by David L. Poole and Alan K. Mackworth. Came out June 13th, or the version of this came out June 13th, 2024. So this is kind of what I've added as the file in my OpenAI assistants. If you're not familiar with OpenAI assistants, it's basically OpenAI's version of Autogen, CrewAI, so forth and so on. Personally, I don't think it's that good. I don't think creating the OpenAI assistants from scratch, right, programmatically is that good. I would still prefer Autogen or CrewAI. Um, but it is fun to use to a degree because you get the models of your pick, right, from OpenAI. The only thing is that the O1 models I don't think are within this. I'm not sure why. Maybe they plan to add it sometime soon. I'm not entirely sure. But yeah, you won't find the O1 models within this. As you can see, I selected GPT 4.0 Mini. Cost does factor into this. So obviously, GPT 4.0 Mini is the affordable and intelligent small model for fast, lightweight tasks. For the O1 model, I am also using O1 Mini. Again, affordable and also intelligent for small model tasks. So again, yeah, the O1 comes in a mini version. So Next, we are going to roll in how to develop a RAG AI or a RAG Autogen AI agent. So, what's cool about this actually is rather than you trying to use something like Pinecone, Redis, so forth and so on, you can kind of set up your own database, I guess, here within OpenAI itself in their vector store, right? You don't necessarily need to kind of go to a third party. You can kind of do it all on the OpenAI platform. So again, this is extremely helpful. For example, if you don't really want to pay for, you know, multiple API keys, right? One for Pinecone or Redis, another for OpenAI assistants, so forth and so on for whatever else you're using. You can kind of just plug all your files into the OpenAI assistant, use it with Autogen. Autogen is for Microsoft. Microsoft and OpenAI work pretty closely together. So it kind of streamlines it pretty well. And then with O1 being here, obviously that kind of makes it even better. So anyways, like I said, this kind of is like your all-in-one stop shop for creating assistants, agents, and RAG models, or AI agent processes that use RAG methods. So again, let's not keep talking and let's kind of jump right in. Welcome. So the IDE that I am using today is Jupyter Notebooks from the Anaconda platform. Um, and I'm using it today honestly because I kind of like Jupyter better than Visual Studio or Colab. I kind of only use those sometimes when Jupyter isn't working in my favor, depending on loading packages and whatnot. So, anyways, today we're using Jupyter. If you're curious. So, first, when we're kind of building this, let's do import logging, import OS from. I'm just going to copy and paste these in. From Autogen, import user proxy agent and config list from JSON. And then from autogen.agentchat.contrib.gpt assistant agent, import GPT assistant agent. So there's already its own package for it. Make sure you import that for the GPT assistant agent specifically. So let's go ahead and run all this. Nice. Then let's do logger equals logging. This is just so that we can get messages back to us. Logger, boom, name, boom, boom. Nice. And then logger dot set level dot logging dot warning. Capital. I think it has to be in capital. Warning. Beautiful. Now, let's do the assistant ID. So the assistant ID that you're going to want to use is the same one from when you created your assistant. You'll find it when you go into your OpenAI account. You'll see whatever you created that assistant within the platform, what the assistant ID is, and you can kind of just use that. So then we're also going to make sure we add our configuration list. So config, like I said, I'm using OpenAI O1 for this, O1 mini. I'm not going to show you my configuration list as it does contain my OpenAI API key. But yeah, config, let's go list, from JSON, OAI config list and LM config equals curly brackets config underscore list config underscore not lust list. Cool. And let's run that, make sure it's all good. Got an error at get logger. Oh, so I think it needs to be a capital L. There we go. So now that we've kind of established our configuration list, like I said, it contains the O1 mini. And now that we also know what our assistant ID is, you then want to start setting everything up, meaning the assistant configuration. Equals curly brackets assistant ID is equal to the assistant ID you already established. Assistant ID, boom. And then we want instructions just in case. There's already instructions there, but just in case, like, I don't know, for any mistake, you are able to add, like if you were kind of creating this assistant brand new, you are able to add instructions to the assistant configuration piece for it to create that assistant just in case. So this is just for me to show you that it is possible to kind of set the instructions and then have the GPT assistant create the assistant for you. Oh wait, this is the wrong one. Whoops. Not this one, not instructions. I want actually tools. The instructions are actually for the next one. I apologize. But we want tools in this actually. And then, boom. And then we want type and retrieval. Nice. Now let's run this. I think I have a call right here. Oh yes. Whoops. That doesn't belong there. There we go. Cool. And then we do GPT assistant, which this is what creates the assistant if needed. But essentially you are adding kind of this assistant config to this GPT assistant this GPT assistant agent. And then we have instructions. And you'll see that where it's like, oh, there is already an agent that we established here. No need to kind of create one or a new one. So it kind of tells you like if an agent's already created or not. And if the agent is not created, it then goes ahead, takes the name, takes these instructions, and creates it for you. Autogen config. So, and also, yeah, I guess, this is another easier way of how to create a OpenAI assistant programmatically without, like, I think doing it straight from using OpenAI's API can be kind of cumbersome, redundant, I guess. I would much rather kind of just create the assistant using, I guess, this Autogen GPT assistant agent. But anyways, let's go ahead and run this real quick. So as you can see, using O1 mini here, override instruction is false. Provided instructions will be used without permanently modifying the assistant in the API. Override tools is false. Using existing tools from assistant API. So that's it telling us that there's already an assistant created. No need to establish these instructions or this name. We are good to go. So now let's create a user proxy so that we can interact with the agents themselves. or agent itself that we created. User proxy equals user proxy I believe that if you are viewing these videos, you are early to the party in terms of where AI agents could go. I think we are getting closer and closer to where we'll see AI agents being more and more used because it's able, now it has the ability, as far as we know, to, AI has the ability to reason, which is a huge jump from where we were before, where, I think agents already had the question, um, the what is it called? The thought chain? I forgot what it was called. The thinking chain kind of already established, right? Agents were kind of already doing that before OpenAI kind of showed it. I think now people are just aware of it, or OpenAI made people aware of it. Chain of thought, that's what it's called. But it was kind of already a thing that agents had that nobody was really using. I think OpenAI just made it popular now, I guess, to use with their GPT models. So again, I think we're just early to the party. I think give it another year or two, and you are going to see where a lot of this knowledge is going to be needed. So if you can become pretty proficient in showcasing that you can build AI models or AI assistants or AI agents using reasoning models where it can, think before it acts for a while, it's going to be extremely profitable, extremely helpful, and people are going to look to you for answers. So just something to think about. Anyways, so as you can see, let's go ahead and actually, let's do this. Let's run this real quick to make sure it all still works. Cool, so no errors. So now we're getting onto user proxy piece where we're able to interact with the agents themselves, ask questions, and ask it to do certain tasks. So we are going to ask it first, please list the topics that this file discusses. Now, this file, like I said, let's not do an exclamation mark, don't want to yell at it. This file, like I said, is this Python code for artificial intelligence. And the topics within it, let's go to the table of contents, Python for artificial intelligence, agent architectures, and hierarchical control, searching for solutions, reasoning with constraints, propositions and inference, deterministic planning, supervised machine learning, neural networks and deep learning. Let's see what else we got here. Learning with uncertainty, causality, planning and uncertainty, reinforcement learning, multi-agent systems. This one might be interesting to learn. Individuals and relations, knowledge graphs, relational learning. So yeah, that's all. As far as us looking at the table of contents, those are the topics that are within this document. So going back to our Jupyter Notebook, we're asking it to list the topics that are within this file, these documents. Please list the topics that this file discusses. So let's go ahead and run it. Still using O1 Mini. Just thinking. And as you can see, error, retrieving file citation. Basically just made it can retrieve a citation from the document we're using. There's no quotes necessarily in it. But as you can see, it's able to kind of spit out what the contents are. So Python for artificial intelligence, search for solutions, things that we kind of already viewed within the table of contents itself. So let's go ahead and pick one. Um, let's try. Let's try. Bayesian learning. Um, I'm pretty sure that with. Oh, let's not do that one. Let's do Q learning, reinforcement learning. Please summarize reinforcement learning from this file. Please summarize reinforcement learning from this file. Let's see what it says. Still thinking. So again, it's when it goes back to search that file, it's basically looking for a quote to take away. There's no quotes in it necessarily, so that's why you're kind of getting like error retrieving file citations, so forth and so on. Nothing to worry about. It's still going to bring about the section of reinforcement learning, and from the file itself, telling you kind of what's in it and what to look for. The section of reinforcement learning from the file outlines various key concepts, structures, and algorithms used in the file. Here is a summary of the major points discussed. Concepts of reinforcement learning, agent-environment interaction, Q learning, experience relay, advantages of exploration strategies, applications and environments, so forth and so on. This overview encapsulates the essential aspect of reinforcement learning, including the structural design of agents and environments, the Q-learning algorithm, exploration strategies, and the utilization of experience relay for enhanced learning efficiency. So now let's say that we want to understand how to even programmatically create a Q-learning algorithm using Python. Let's see if it can kind of spark that up for us. Based on the file, can you provide a coded example of, what was it? Coded example of a Q learning algorithm written in Python? Question mark. Let's see what it brings back. Based on the file, can you provide a coded example of a Q learning algorithm written in Python? So let it think, let it process. O1 does take longer to kind of think through a question. Again, it's that chain of thought, right? In the back end, it's kind of going through a bunch of different scenarios, a bunch of different questions, asking itself kind of a logic of thinking to then give an answer. So here's an example of Q-learning algorithm written in Python based on the code fragments found in the document. Python random math class QLearner definition initialized So as you can see, it's able to kind of look through that file, find examples for you, pull that out, and show you kind of what's in it. Example actions: left, right, up, down, agent, simulating interactions, Cool. Okay. So explanation. This code defines a QLearner class that implements the Q-learning algorithm. The init method initializes the Q values and visits count for each. Epsilon greedy method is used to choose whether to explore or exploit based on the current Q values. Now, how is this useful to us? What's the point of learning this? Is how or what use cases would this code, what use cases would the Q learner algorithm be helpful in? And let's see if we can find out. Now, again, huge document, um, very data intensive questions that provide an explanation to a lot of things and code. Um, so, game AI, robotics, autonomous vehicles can help in decision making process for autonomous vehicles. Blah 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 blah. Blah. Financial trading. Agents can learn trading strategies that maximize profits based on historical data. Healthcare, smart grid management, personal assistance, leveraging for better decision making, learning from the optimized supply chain optimization. Um, let's say, can you code me a Q learner algorithm for let's do financial trading, or let's say, can you, I don't know why I said code me, can you create a can you create a Q learner algorithm written in Python for financial trading? Let's see. This is a new question that I haven't done. Let's see what happens. I'm curious. Can you create a Q learner algorithm for written in Python for financial trading? I missed right there, but it's all good. Let's see if it kind of is able to handle that, right? I'm sure that it notices a mistake, and it is trying to determine what I mean. And again, through the back end, able to use chain of thought to kind of create it. So let's see here. Clearly, certainly. Below is an example of Q&A algorithm implemented Python where simplified. This example is a simplified scenario where agent learns to either buy, sell, or hold a stock based on historical price data. The implementation includes setting a basic trading environment where rewards are based on the agent's action. Beautiful. Q learning algorithm for financial trading. So as you can see, let's just go through the whole thing, right? We started off with saying, please list the topics that this file discusses. It listed out the topics based on the file that we kind of already uploaded to the AI agent. Then please summarize, we picked a topic and said, please summarize reinforcement learning from this file. It gave us a summary on kind of what the concepts were when it comes to reinforcement learning in that file, in those documents. And we picked the Q learning algorithm. Q learning is a power algorithm with reinforcement that allows the agent to learn the value of its actions without needing a model of the environment. So with that, we said, based on the file, can you provide a coded example of a Q learning algorithm written in Python? Here is an example of a Q learning algorithm written in Python based on the code fragments found in the document. So it's able to take examples and information from the document that relate to code and also give you those references, or give you an output of those references here directly from the document. But sometimes like you kind of want to go on a tangent and want to kind of ask it questions that maybe are outside of the document, even though it knows about it. What use cases would the Q-learner algorithm be helpful in? It gives you ideas. It gives you kind of a variety of ideas of where we picked financial trading, right? Can you create a Q-learner algorithm written in Python for financial trading? Didn't mean to include the for there, but again, O1 is smart enough to know what I meant and give me a algorithm that can be used, and provide an example of a Q-learning algorithm implemented in Python for a simplified financial trading environment. So again, this is one way where you can learn. Let's see the explanation actually. Trading environment. This class simulates a simple trading environment where the agent can perform 3 actions: buy, sell, or hold a stock. The agent's profit is determined by the actions taken based on the stock prices. Q learner. This class implements the Q learner algorithm based on epsilon restrain strategy. Updates the Q value after each action using the template. This example runs a few episodes where the agent learns from the simulated trading environment using historical stock prices. After the learning phase, it prints out the Q. This is a very similar. Does it take into account transaction costs, slippage, or proper state representation? So it's even able to tell you like, hey, this isn't perfect. Here's some things to note. And in practice, management can be very complex and require more sophisticated approaches, including deep reinforcement learning, to be effective. So again, This can be extremely helpful where not only does it give you an example, but it also tells you like, hey, this is an okay example. This is just a very simplified version of what you're looking for. What you'll need is maybe including deep reinforcement learning to be effective. So it gives you ideas on how to not only create the example, but how to improve it. So let's ask another question. Uh, can you, okay, let's do please include deep reinforcement learning in the example. Let's see what it does. Either A, it could tell us like, hey, I'm going to need more information, blah, blah, blah. Or it's going to be like, hey, sure, here's an example, but again, it's very simplified. So with another question like this, it then performs that chain of thought reasoning and thinking in the background. And who knows how long this might take, right? O1 mini or just the O1 series are models that are highly sophisticated. So again, it provides, ooh, this one's huge. So it included NumPy, TensorFlow, Keras, blah, 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 blah. Simulated another trading environment. So yeah, it's Keras, sequential. Oh, added layers and dense layers to it. Okay, cool. So again, this is another example, right, where it's able to provide a note or provide a suggestion. You can decide if you want to take that suggestion to then modify or improve the agent process you created. So anyways, I don't want to make this video any longer. I was getting carried away for a while. But when you're having fun, who cares? Let's see. No, this is still okay. Even after its output, it still says this is still a simplified approach and does not include critical factors such as transaction costs, portfolio management, or feature engineering for the state representation. In real financial applications, a more sophisticated setup is required with more complex neural networks and training strategies. So again, this is O1 Mini giving you a start, right? And I'm sure if you wanted to, you can add more documents into the assistant that maybe relate to financial data, financial strategies, financial applications of examples or examples of financial applications, so forth and so on. Again, you could take this as far as you want. What my job here today was just to show you how you can piece it all together by adding not only Autogen, but also adding OpenAI assistance, but also adding the most sophisticated model out there, the O1. This is the beginning of, I believe, the ability for you to build agents and include different tooling, different sophisticated models, different platforms, right? Autogen is technically Microsoft thing. OpenAI GPT models is OpenAI's thing. But fusing them together is where it gets really important, even if it's also just fusing the OpenAI assistants, right, which is their kind of own agent product, as well as Autogen agents, which is Microsoft's agent product, fusing them together to kind of create, I guess, the ultimate AI agent process. That is where we are, and that is what makes kind of this example, this tutorial, and this how-to really important. So anyways, I hope you enjoyed the video. Please make sure you subscribe, you like, you suggest, you comment, even dislike, whatever you want to do. I want your feedback. We want to hear your feedback. Feel free to leave comments on other ideas that you want us to try. We want to make sure that we are giving you and providing you a great experience and learning how to use agents for your own benefit. Anyways, until next time, guys, bye bye.